Welcome to the Software Engineering channel on YouTube. Today we're going to discuss arrays, strings, and memory with regards to C++. So, what is an array? Well, in C++, an array is a collection of data elements of the same type that's stored in a sequential and ordered fashion. So, suppose we were tracking arrays for exams for a class of, say, 10 students. Without an array, if we store these, let's say, as integers, we would need to store them as 10 separate variables and then have to manage them as 10 separate variables. With an array, we can declare them as a single variable and store all of the grades in that one single variable. In C++, arrays are stored contiguously in memory. This means that the memory location for the second element in the array is directly after the first. So in this picture here, let's say this is assuming we have 4 arrays. We have like a peach colored array here that has 2 elements in it. You notice they're right beside each other. Then we have a blue array where you have the 3 elements right next to each other, and a green array, and then the purple array. They're all right next to each other. So in C++, this would be array element 0, 1, and then you'd have the blue 0, 1, 2, 0, 1, 0, 1, 2, 3. Note that in C++ arrays are 0 based indexed. If it was not contiguous, it might look something like this, where everything's just kind of mushed all around. You can see that the 2 peach elements are separated, the blue elements are separated, the green. The purple ones just happen to be together here, but that would not necessarily be the case. So, how do we access elements of an array? Well, C++ has a brace operator. It's the 2 square brace, and you put a numeric index in between them. This tells you which element you want to access. You can also declare multiple dimensions by using more braces, and the limit of the dimensions that you can declare really depends on your system, but it's very unusual for you to find a use case for more than 4. Before we move on, I also want to mention that the standard library has a template class for arrays that we'll use in the demonstrations. And this it's not necessary, but it will allow you to keep things consistent with other standard library classes, and you'll see what I mean when we get into the examples. Strings are a special kind of an array. These typically are things that you're going to display to the end user, and these are visible markers typically. C-style strings are created using the char or char star, so we'll show that in the examples. C++ in the standard has a wrapper for these that is specific for string. It's called the standard string template, and this manages the memory and at the end a string marker, so the programmer doesn't need to. And we'll see that in the examples as well. I'm going to introduce all 3 types of memory that C++ supports. We aren't going to go into a whole lot of detail on the last one right now, but so there are 3 types of memory. There's automatic, dynamic, and static. Automatic memory is what we've seen so far, where you declare a variable. Its scope is limited to whatever scope you've specified it. So if it's in main, it's only in main. If it's in a function, it's only that function. You might also see that this type of memory referred to as the stack. When you declare the variable within the scope, it's only valid within that scope. And once the scope ends, the variable is destroyed. The memory is allocated at the time the program is compiled. So all the memory you need with this kind of storage is known when the program is actually compiled. Dynamic memory is something we have not looked at yet, so we're going to introduce that today. And you might see this referred to as the heap. Creation of dynamic memory involves using the new or new with a brace keywords, and the memory is allocated in such a way that it will remain allocated until you free it with a corresponding delete or delete brace. If you do not free this memory, the program will continue eating memory. As every time you call whatever function it was allocating it, you're just going to allocate more and more memory. This is what's referred to as a memory leak. You want to avoid those. Every new must have a delete. We'll look for ways the standard library can help take care of this, so you don't have to track it yourself when we get to smart pointers much later on down the line. However, we'll also look at some of the standard library classes that wrap this for you, which makes it a lot easier to avoid some common memory leak problems. Static memory is the one that we won't dive into terribly deeply right now. it's a little different. The variable is limited in scope, but it exists until the program ends. I'm mentioning it now just for completeness, but we'll talk about static variables much later on. And finally, let's get to some examples. All right, so our first example, as we mentioned, let's say we have, and I'm going to use the example of grades. So let's say we wanted to calculate the average for an exam, and we're going to assume right now we have 10 students in the class. So we've created our exam name. We have the 10 students. Notice there's 10 variables. To calculate the average, we have to create a function or a mathematical operation to actually calculate the average. Note that I'm using integer arithmetic here, so it's going to just truncate any decimal place, which is fine for what we're doing now. And it's just going to print out the average. So if we come over here and I go into notice it goes ahead and prints out the course average. And you can calculate this to verify it if you want. It is going to just truncate the decimal place, so it's not going to be precise here, as I mentioned. Now, this obviously, if we add more students, becomes rather annoying because we have to add to this. We also have to add new variables. We have to increment this value. All things that are really a pain in the butt. So how can we streamline this a bit? Also note that in these examples, I'm going to cover two things at once. I'm going to introduce strings as well. So here, I'm going to go ahead and create a max string size and set the exam name. This will be the default exam name. It's going to be all zeros, and then I'm going to ask the user to input the exam name. Note that I'm using the getLine function from the console input, which will grab the entire line all the way to the end of string character or into line character. And then I'm doing the same thing. I'm going to go and I'm also going to introduce the concept of a loop here. So we have not done loops yet. We haven't done any of the control structures, so this will be the first one we touch. And loops and arrays go hand in hand quite often. The for loop is going to start with a variable I, and I is going to start at 0, and I'm going to continue until I is greater than this class size variable, which is set to 10. And I'm going to increment. So as long as I is less than, it's going to be greater than or equal, but as long as it's less than class size, it will continue incrementing I. Once it reaches class size or higher, it's going to exit the loop. And each iteration is going to prompt me to enter a student's grade. At the end of it, I'm going to then have another loop that goes through and totals up the grades. I could, in theory, do this in the same loop, but I'm separating them for demonstration purposes. And then I calculate the average grade, and we're going to get similar output. So let me go over to so just to show the same output, let's go with the same grades. And we get the same output. So here the difference between the two is we've prompted the user for the exam grade. This is what's called this is the C-style constant string up here that was in the first example, and we had the 10 variables. We've now changed it where I'm declaring a string of a maximum size of 20. I'm asking the user to prompt for the exam name, and then I have a class size of 10. All this is hard-coded at this point, and I'm going to prompt the user for the grades to go in there and then calculate the average that way. So what's next? Here, we're We're going to keep the same method for entering the exam name, but I'm going to introduce the first standard template library operation outside of input-output, which is the template class for array. This will function very similar to the array that we just declared in the previous example, this guy right here. The difference is it also has some functions that are built into this class that are very similar to other standard library functions, which allows us to do things like use the standard library accumulate function, which will sum up all of the things in the array very nicely. So here, same kind of concept. I'm still declaring, I'm hard coding the size. I'm asking the user to input all the grades. And here we introduce the first function in the standard library that we're using, which is accumulate. This will start at the beginning of the grades, which is going to start at 0, and it's going to go until it reaches the end. So it's very similar to a for loop here, and it's going to start the count at 0, very similar to what I did with the previous for loop where I had initialized total grades to 0. It's going to do the same thing, and then it's going to return the total grades, and then I can then do my division and I get the same result. So let's again, I'm going to use the same numbers just so we can show that it's actually doing the same thing. And you see I get the same output. Next, we're going to introduce the concept of dynamic memory here. And we as I mentioned in the introduction, all of this gets determined at runtime, whereas everything we were doing here is determined at compile time. Notice that this is all hard-coded. The size of the array is hard-coded. Now I'm going to determine the size of the array at runtime. And when I do that, I'm going to end up declaring and using the new keyword, which is going to allocate memory. And we're going to do this both for the name and for the grades that get entered down here. So this is going to require me to enter a size, create the new array dynamically, and then I'm going to have to jump through some hoops to make sure that it gets cleaned up. Specifically, make sure that this gets run. All the other code is largely the same. There's some tricks here with the input. Ignore that. It's doing the same thing as the previous one. It's just avoiding some character differences in the stream. Oops. So I'm going to set the max length to 20. Let's keep it at 10. Helps when I don't mistype something. So let's rerun this. Oops. Sorry. And you can see that I get the same answer. Note that this errored out because I put a plus sign in here where it didn't recognize the plus sign as a valid number, as it shouldn't. That's because I have no error checking done in this code, and that's for simplicity. In production code, obviously, you would make sure that you handled invalid input. I'm not putting a whole bunch of error checking into this code right now, simply because we're trying to show some simple examples to get your feet wet. And moving on to our last example, we're going to introduce a couple more standard library templates, the string class and the vector class. The string class it will handle all the memory allocation and end of marker for the string, so you don't have to worry about that as the programmer. The vector will handle all of the memory management for a dynamic array. So before we jump into compiling it, you'll notice that I no longer have to put the size for the string. I do have to put the size for the vector. There are ways you can get around this as well, but I didn't want to complicate the example, so this is just for simplicity. And then entering the grade still, I can now, you notice that the same method for accumulate looks identical to when we used it for the, I believe it was this example, yeah, example 3, where we can use the begin and end functions. Vector has those as well, so you can make it identical here. This is part of the reason why when you're using C++, you might consider using the standard array class, because if you ever have to switch it to a vector, if you're already using a lot of the standard functions, you won't have to change much. And then everything else is largely the same. And we get the same answer again. Note that if I wanted to run it here and just to, let's say I put 2 and I have 125, note that it handles the difference in the size very easily. So I could have any number of students in my class and it would not matter. My program would still function. I didn't have to worry about over allocating memory or under allocating. I can do the same thing if I enter 20. So if I run the program again, just going to make up some numbers here. Let's say we have one person do really bad, and you can see it handles 20 students just as easily as it handled 10 students or 2 students. That is the introduction to strings, arrays, and memory allocation. We'll start getting into functions and classes here in the next couple lessons. See you next time.